Okay, in this video we are going to be looking at question 8, part A, of the June 2014 Edexcel FP1 paper. And the question says, the points P, which is given with coordinates 4k squared 8k, that's all that notation means, P has those coordinates, and Q has coordinates k squared 4k, where k is just some constant, don't worry about that, lie on the parabola C, which has this equation, y squared equals 16x. It then says the straight line L1 passes through the points P and Q, okay? And the question asks us to show that the equation of the line is given by this thing here. Now, this looks like an absolutely horrendous question. I must admit, I first read it and I thought, oh my word. But actually, you look at it and it's really easy. When you get involved and when you get into it, it's actually really easy when you realise it. It's just basically using the maths which you studied at C1. So the first thing which you need to do is you need to, well, I mean, I like to draw things first, just to kind of get a visual idea of what's going on, particularly when doing things to do with graphs, because graphs, the whole point of graphs, they're a very visual relationship, very visual way of showing things. So let's take the equation, y squared equals 16x. Okay, let's rearrange it to just get y on its own. So y is equal to the root of 16x, which is, of course, by surds, equal to 4 root x. So basically, it's a root x graph, which has a scale factor of 4. Okay, and yeah, so that means we can then plot it. I can then plot P and Q on here, and you can then plot the line L1. You know, there's nothing really difficult about plotting it. So basically, it's just finding out what is the equation of a line. Remember, the equation of a straight line is given in the form y equals mx plus c, okay, where m is your gradient and c is your y-intercept. Okay. And so basically what we're going to be using here is a little formula. So first of all, first thing we need is obviously m. Remember that m is given by a change in y. M is the gradient, so it's given by a change in y divided by a change in x. Okay. And you can see here the change in y, this is why it helps to draw it. The change in y is 8k minus 4k. Okay. And the change in x, well, that's given by 4k squared minus k squared. So that thing then is equal to 8k minus 4k, so we've got 4k, over 4k squared minus k squared, so all in all we've got 3k squared. Okay. Literally I'm just saying 8 of something minus 4 of that same thing. How many of that thing have I got? Well, 3 of that thing. And the same thing, 4 of something minus something. How many of that thing have I got? I've got 3 of that thing. Okay, I can do a little bit of simplification. The numbers remain the same, 4 and the 3, okay, but you've got a k on the top and a k squared on the bottom. There's a little bit of cancellation, so one of those k's cancel off with one of the k's on the bottom, so you're just left with 1k on the bottom. And that is your gradient, okay, 4 over 3k, that's your m. Where do we go from now? Well, we use this little formula. We use y minus y1, so we choose a coordinate basically. Y minus y1 equals m times x minus x1. You should have seen that in C1. And that really lies at the central part of trying to find the equation of a straight line. Okay, remember this comes from, let's say we have, I don't know, let's say we have a straight line. Okay, we pick any 2 points in that line. Let's say we pick this point up here, let's say x, y. Well, you can always find a point which is however far you want away from it. Let's say away from this point, let's say that point is x1, y1. You can choose any point you like away from this point. Okay, and the gradient will be given by the change in y, remember, by change in x, which in this case is, change in y is y minus y1, and change in x is x minus x1. Okay, and then we do a little bit of rearranging, and we get, let's get y minus y1 on its own first, equals m, we multiply through by x minus x1, x1, and there we go, there's our little formula there. So that's showing that it's not kind of like just appearing from nowhere. This is really simple, showing this is how you work out the formula of a straight line. Okay, so we've got our m above as being 4 over 3k. I think I've changed the, yeah, that's better. 4 over 3k. Okay, and we would choose one of the points. Let's say, let us choose, I don't know, which one do you want to choose? Let's choose P. So 4k squared and 8k. Okay. So, what are we doing? So, our point x1, y1 is equal to 4k squared, 8k. Okay, I've just chosen one of those points. You could have chosen the other point. That would have been absolutely fine. Okay, now sub it into our formula, y. So we say using y minus y1 equals m times x minus x1. We get y minus y1, our y1 is 8k, equals m, which is 4 over 3k, times x minus x1, our x1 is 4k squared. Right? And then we do a little bit of manipulation. Remember what we're after. We are after this thing here. So we want to give it in this answer. Okay? So 3ky minus 4x equals 8k squared. Right. So let's just multiply through by 3k. Okay, because we've got a denominator here. So let's do 3k. There's loads of different ways that you can do this. This is just the way which I'm going to do it. I'm going to get rid of the fraction first. Equals, because I don't like dealing with fractions, x minus 4k squared. Okay, so multiply through by 3k. So 3ky minus, what's this? 3 times 8 is 24, isn't it? K squared, k times k, is equal to 4x minus 16k squared. Right, let's do a little bit more rearranging. Remember, we're after, I'll write it down here what we're after. 3ky minus 4x equals 8k squared. This is the thing which we're after. Okay, so we've already got the 3ky. Let's take the 4x over this side. Okay, because in the answer the 4x is on this side, so let's get the 4x on this side. So we've got the left-hand side. Now let's get the right-hand side. So we've got minus 16k squared. Let's take the 24k squared over to the right, so that becomes plus 24k squared. That then implies that we get 3ky minus 4x, thing which we want at the left, is equal to 8k squared. There we are. There's the answer. That's the answer which we want. Okay, where are the marks for that question? Well, let me just get the mark scheme up. There's one mark for trying to find the gradient. Okay, so a valid attempt of, they say a valid attempt of trying to find the gradient, showing that you know that the gradient should be changing y over changing x, even if you don't use the right numbers for some reason. You could have done it the other way around, of course. So if you've done 4k minus 8k over k squared minus 4k squared, that would have been fine, because you would have got, I'll just show you, you would have got 4k minus 8k, that's minus 4k, over k squared minus 4k squared, that's minus 3k squared. Negatives would have cancelled off, okay, because it's negative 1 divided by negative 1, and likewise the k would have cancelled off there, so you still would have got 4 over 3k. Okay, so that would have been absolutely fine. So you get 1 mark for showing that you know how to use the gradient. You get 1 mark for actually getting the answer in terms of k. Or do you? No, you don't. You get 1 mark for showing that you know how to do the gradient. You then get another mark for showing that you know this method. You know how to use y minus y1 equals x times x minus x1. So this thing down here. Okay, and then you get another mark for actually getting the correct equation. How many marks a question out of 4? Mark scheme's confusing me. 1, 2. Yeah, you get 1 mark for the correct equation. Yeah, you get 1 mark for using the correct equation, and then you get an extra mark for getting it in this form of the actual answer. Yeah, sorry, that was confusing me because it's saying you get 1 mark. Yeah, That's fine. So you get 1 mark for using the equation correctly and getting it in some form. So say if you got it to this form here, they'd give you a mark. Okay, so you multiplied out and everything. And then they get an extra mark for actually giving it in that answer, because the question does clearly say, show that the equation of the line is given by this thing. Well, you know, that thing doesn't look like that thing just yet. You have to do a little bit extra work. Okay.